Hi everyone, today I had the pleasure to sit down with Brent Fikowski. Brent is not only one of the fittest humans on the planet and also a role model for many in the functional fitness world. He is the president of the PFAA, which is the Professional Fitness Athlete Association. And that group represents and supports the needs and interests of athletes who compete in the functional fitness world. We talk about equipment used during elite competitions and more specifically the sledges as well as the air runners. Maybe some of you remember that during the 2019 games there was a lot of talk about that some lanes were faster during the sledge events. We want to actually study this. Therefore, we recorded this podcast because we are searching for engineers and people who have a technical background in biomechanics to help us out with this study. So if you know or yourself such a person with that technical background, please just send us a message and we are happy to collaborate. But without further ado, this is my conversation with Mr. Fikowski. So hi Brent, thank you for joining this conversation. Today we are actually gonna talk about something really in detail, and that some people certainly at the highest level have talked about. I think quite a bit, and that is actually the, let's say, the standardization of the sleds or of other machines, even also runners potentially in high profile and high level CrossFit competitions, right? Because there was some chatter, let's say, that these sleds were not all the same, or at least the turf was not all the same in every lane. And I think you have been bringing up this topic quite a lot, and also you know quite a lot about it, obviously with your massive experience. And maybe I'll just start with how it all
Yeah.
ignited, right? So it was. Not so long ago. I mean, 2019. A friend texted me and says, "Hey, man, this event at the games 2019. You can see it here on the screen. The sled push, bar muscle up, and then sled push event, which was basically just a sled event because the bar muscle ups. I mean, correct me if I'm wrong. Were not really too important here." He said, "Yeah, man, there's a couple of lanes that are statistically lower, like the slower and also faster, obviously." So we went a little bit into the details of this, and you can see here quite clearly that. So these are individual dots. There's some slow lanes, lane 8 and lane 16. So of those events that the people were slower, and then you also have some faster. This may be even more important. Some faster lanes where there's little variation between the people who actually did that event, and they had much better rankings. You see here the ranking and as well the lane assignment. Good. So maybe can you confirm, or is there anything related to this into the athlete world? Have people been talking
Yeah, I
about
mean, that
this?
was definitely the first time that there was like a lot of kind of public chatter about the
Yeah.
lanes being uneven or unfair, I suppose. And that was especially important because that year there were cuts, right? So you had athletes that seasons,
Yeah.
ended kind of or they continued because they were in a good or a bad lane. So it just magnified the issue. And like you said, the event was you pushed it down the field. Let's
Yes.
say it was, I don't know, 40 meters, 30 meters. You did 18 bar muscle ups or 15, I think, for the women, which everyone was able to do unbroken. And then you pushed it
Yes.
back, and you could visually
Yes.
see some athletes were moving, moving their sleds like they were just running with them like a shopping cart, and others were really trudging. And speaking with athletes, speaking with some coaches, they were anecdotally saying something like, "Oh, two of the athletes in this field I coach, and if we do a workout in training, 10 out of 10 times athlete A will win the sled workout. They're just good at pushing sleds. Their absolute
Yeah.
strength is just a lot better, and those sorts of things." And then in this event, they lost by a minute to their teammate. And he's like, "I don't really attribute that to the person like rising to the occasion." He's like, "I'm pretty sure it was, the sleds were unfair." So I won't put names to that, but and yeah, and then but
Yeah.
athletes have been talking about this before. I know in 2014 at the CrossFit Games, I wasn't there, but I'd heard athletes talking about, "Oh, you know what? This was when they still used the grass field in Carson, California. The soccer field is what they would call it."
Mm-hmm. Mm-hmm.
And athletes would complain like, "Oh, my lane had dirt. That the grass was kind of had broken down into dirt, and other athletes had like really soft grass or, short grass or long grass. And then even in 2016, when I was there, the second to final event was called the rope chipper. And we had to hand over hand pull
Uh-huh.
this sled across the stadium floor, like a rubber kind of floor. Or might have just been matting on concrete. Either way, there was one lane that had like a lot of stickers on it, like logos and, like branding and that sort of thing. And that lane was moving slower according to, the discourse that was going on in the back. And is there any way to prove that? I mean, not anymore. And then even this year at the alpaca, we did the alpaca last year and it was raining and no one really
Hmm.
complained too much about the sleds
Yes.
then. But this year there was definitely some talk again where they felt the sleds were inconsistent between lanes. Athletes were feeling that way. And so I think it's just time for us to, and even you look at a sport like high rocks, it's becoming a very popular sport, and they
Good
are
point.
consistently doing the exact same workout every time and claiming world records. And a big part of that event is pushing a really heavy sled and then doing a hand over hand rope pull. And so, it's important that we're like, all right, is this something that can be standardized? Are they standard between lanes? What are the factors you can do to increase the fairness between lanes? Like, I think those are all questions that can be answered with some good testing. And just no one, at least none of the testing, I've done some Googling. And so I haven't found any. So I think it'd be valuable to do some thorough testing and kind of see where we're at and then see if there's a way that we can, still use sleds. Cause I like sleds. I mean, it's not really in my interest to do this testing. More often than not, when there's a sled in a workout, I do really well, regardless of how fair it may or may not be. I mean, I came third and first this year in the two workouts with sleds. I came first, and third in the three workouts this last season with sleds at the semis and the games. So I don't really need it to change, but I would like to know that, when you're when you use a barbell, it's the same. When you use rings, it's the same. The Concept 2 machines are the same. And so, kind of the final frontier are like the air runners, the echo bikes, and the sleds. Those are kind of the last three things. Everything else, we know you just weigh it and you're like, all right, sandbag weighs 200 pounds, moving on. Yeah.
Yeah. Yeah, so obviously very valid point, and one way. So I've been thinking about this, and that's also why we started up this conversation to potentially get people involved who are listeners and who know a lot about this biomechanics, and yeah, just more engineers. I'm not an engineer by training. I'm a sport scientist. So what you could do is put. It's actually very straightforward. You put a dynamometer meter, so it's a strength, like a force meter, onto the strap in between, let's say, the strap and the sled, and then you would have a standardized pulling mechanism, not a human, obviously,
Yeah.
because yeah, your demo team will get tired, and it's all subjective. You need some kind of robot or something that pulls at a certain constant velocity, and then see if there is more friction because of certain lanes. I mean, that's basically the most
Yeah.
important. That if there are different lanes and obviously different sledges, but I think mostly, I mean, I'm not 100% sure, but mostly the lanes will have the most effect on the friction between the sled and whatever the field. This you could relatively quickly test before an event, where you have all the sledges yeah, lined up, and then you have just a constant pulling, and you see if the force is higher within a certain lane or lower, then you would think, okay, the friction is lower, so that person will have an easier time or harder time to push or pull the sled. So this even, I mean, that's not even a scientific study. That is just something that CrossFit or Hyrox could do and should do. I think certainly at the games and semi-final level. I mean, it's so important nowadays. So that's one thing I think about. If there are listeners who can comment on this and even yeah, provide more information on that. Just put a force dynamometer between the straps and the actual yeah, sled, and then just pull. Then you know already really a lot, and I would be highly interested to see if there would actually be more than whatever 5 to 10% differences between sledges and between yeah turfs. That's
Yeah.
the whole point. And if this is the case, yeah, then we have to think about
Yeah. Yeah.
changing
I think,
this.
yeah. So anyone that is watching that has the wherewithal and the knowledge that would be interested in partaking in this, send wod-science a message.
Yeah.
I'll be involved as well. And, I
Yes.
think
Yes.
yeah, I think there's like some, we've talked obviously a bit about like what that testing could look like. I don't, have an engineering background, but, I took physics in high school and did pretty well. So I get this
Yeah,
stuff.
yeah. I mean, it's
Yeah,
basic physics, to be honest.
I think, just creating some controls and then really like, the question you want to know is if we have athletes in, let's say, 10 lanes, are all the lanes the same? And then over the course of, let's say, a day, if there's four heats of 10, are the athletes in the 10th, in the fourth heat experiencing the same thing? So maybe is there like is there enough heat from maybe whether it's the sun or also like, I mean, I know from experience when I'm pushing a sled on asphalt that has a steel, by the end of the workout, it gets really hard. And I'm like, I don't think I'm this tired. I'm pretty sure like the heat on the steel is causing it to like stick to the asphalt. Now, obviously, we don't see sleds being pushed on asphalt that often, so I'm not as worried about that. But definitely, just really the two main surfaces are, artificial turf and rubber. Those are like the two main surfaces that we want to
Yeah,
test on. And then there's sort of three sleds and then three types of movement of the sleds. So the sleds can be pushed like you'd push a car.
yeah.
The sleds can be pulled usually like with a harness, and
Hmm.
that's where you usually see the most weight. So sometimes you'll see athletes push a sled that only has 100 pounds on it, and they're pushing it pretty slow. And then you can pull that same sled and run with it when it's when it's a harness, because I think it has less to do with friction at that point and more just the actual load contacting the ground. And then the third way that you'll see sleds being moved at competitions is with a long rope where you're standing in place and you're just pulling it. And then there's just
Yeah,
there's obviously like, there's an unlimited amount of types of sled, but there's some that are more common than others. There's mostly the two ski sled where, the sleds are, 80 centimeters by like, what is that, 4 inches or 10 centimeters, kind of these long skis. Oh my God, did a little heart. And then, or there's, yeah, and then there's
didn't know that.
the large surface area, like the size of like a laptop or a screen, where it's just this big hunk of metal.
Yeah,
And then at semis this year, we used instead of the big hunk of metal, it was a big piece of fabric, which also, people felt there was discrepancies between lanes. Obviously, the fabric was kind of like coiling up, but then some lanes were covered in chalk from prior workouts, and others were not. And it's like, oh, that makes it easier. And so I think there's a lot of different testing. Once we get started on it, you can experiment with like, well, what if the rubber's covered in chalk? What if the turf is covered in water? Which was,
yeah,
the 2019 example. That was what people pointed to, was the lanes that were going faster. They felt that they were behind the mister fans, right? So there's these big, huge 6 foot tall
yeah.
fans that had water to cool the athletes, which is great. But then those lanes might have been a little more wet, and so the athletes had an easier time.
Yeah, it all comes down to engineering a machine that can pull at a certain speed. Yeah, that's mostly basically it. And then you just attach different sleds with different weights, and then you just change the surface of of how it would be in an actual competition, adding some chalk, adding
Yeah,
some
yeah,
beer, adding some water,
the beer.
and and if this is like negligible with say 1%, 2% difference, okay, then we know it's probably some subjective athletes are talking, and maybe it's not really true. But if they are 20% difference, when there's a little bit of moisture, which I actually could believe, in friction, which you can, as I said, quite easily test. This would be obviously very useful also for CrossFit and for other organizations to know what can actually happen and how the sled can be affected. So we just, at this moment, I don't think we know the actual
Yeah,
magnitude of the effect. Maybe it's very small, or maybe it's 20%, and then it gets more important. So maybe that's the first step. If anyone is listening, how we can do this is just not even in a CrossFit setting, sorry, in a competition setting, but just on the field, and just test the magnitude of differences between different
yeah,
frictions. I think that's the key
yeah, exactly. Yeah,
here,
yeah, I
and
think
how
like
big it is.
just starting there and seeing how different it is, and then I mean, I would love it if we just we put water, we put chalk, and it's just like all that matters is the weight. I'd be
Yeah,
like, great. I also think what might change is if we find a way to you pull the sled, and then maybe there's a way to set it up where it pushes, or you maybe simulate a push by putting the straps on like the other side of the sled, so it's like you are pulling it,
yeah,
but you're doing it from the other side. Maybe it's found that the friction is so much more important. Again, this is me not being an engineer, but maybe you find maybe the recommendation is like if you're going to have sleds at a competition, they need to be pulled, right? Like maybe like
yeah,
here's ways you
yeah,
can pull the sled that regardless of the surface, it's close enough, and you can do a little bit of a test beforehand and just make sure the field's dry or clean or whatever it is. And then it's like you can pull the sleds, which
yeah.
is the same stimulus. You
It's
can still put your arms or have your shoulders. It's going to affect your body the same way
yeah,
from like a training and testing standpoint.
yeah,
But maybe the recommendation is like don't do like the prowler push because in that instance the friction any change in friction between
yeah.
lanes is magnified so much more and kind of makes
Yeah,
sense
magnified.
again looking back and from my own experience like I can pull a 600-pound sled on turf and it's pretty hard and then if I try to push it it's going to feel the same with like maybe 100 or 150 pounds so obviously the something else is making it more
Yeah,
difficult. I didn't change. It's the friction that's causing it to be harder. So maybe that's what's found. But I think
yeah,
the testing needs to be done to have a starting point, and then it's about like, okay, what's the application for that in a competition setting? Can it be standardized? Do you have to get rid of it? Do
yeah,
you have like an option of okay, we have a backup plan? Like if the sleds aren't consistent, then we'll do lunging or there's there like a backup, right?
yeah. Or certainly at the games, it should be tested before the games start.
Yeah, and
So
and then
you
you
know
need a backup,
already.
right? Because it's one thing to have the test, and for you to do this test and be like, huh, 30%. Well, good luck, And I think that's sometimes what can happen at a competition like the games. There's so much going on. They have all these moving pieces, and they go, oh
Yeah,
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 well, maybe we'll test for safety, we'll test for fairness. It's like, yeah, that only matters if there's a backup plan, if there's an option, right? If it's absolutely pouring rain, it's like okay, we'll do, we won't make them
true.
run in the rain, which is fine. But like, let's say it wasn't because the surface was really slippery. It's like, okay, you need a backup. You need indoor treadmills, or we're gonna bike, or we're gonna but
Yeah,
bikes. You have to have a backup if there's a possibility that something you're gonna do is like, oh, we're not sure if that's gonna be consistent. It's like, well, then you need a backup, right? So
yeah. Yeah,
yeah,
I fully agree. I fully agree. So yeah, maybe we can touch on that as well because actually a similar thing happened. If I I'll just quickly share the data as well from our from our post. It's not really from a post. It's just from this is from so that's, for example, such a machine. I was looking at this. So these are very quite cheap. This only goes 30 kilos, but there's more. These force transaction meters that you can just buy, and then we can relatively easy test these things. The more difficult part, maybe just as to finish, would be to construct or to have a machine that pulls at a certain velocity and also is strong, obviously, that can pull 100 200 kilos. So this, at the top of my head, I think we need some engineering, but I mean this must be also pretty straightforward to do. Yeah, because it's very important that is constant and without any human bias. It cannot be a human that tests
yeah.
this. It has to be, yeah, a machine that pulls at a
You need a
certain
you need a
strength.
really
So that's, but
you need a
that's, I
really
mean,
strong
doable.
golf cart on cruise control.
Yeah, that's the thing. It has to be
Yeah,
on cruise control and something along those lines. I mean, it's a. I work in a physiology lab, and there we have like these leg extension machines that move at a certain speed, like a certain
yeah,
degrees per second, and yeah, you can pull or push as much as you want with your leg. The machine still goes up or down. It's stronger than your leg muscle. So something around along those lines for this would be
yeah,
would be ideal. Um, and then, yeah, maybe something interesting as well, and maybe a little bit more difficult also from an engineering point of view. And if there are people again that are more that know more about the technicalities of this, would be here and the semis last year,
yeah,
if I'm correct. Um, there was also some chatter about a certain lane that was faster because the air runner was not the same or differently calibrated. Good. Again, this is not complete correct, or this is not foolproof. It just shows that this lane was significantly slower than the rest of,
Yep.
you see it here, than the rest of the lanes involved. Is this can still be because of pure randomness, or yeah, just happens to be there, right? But it's still, it's significant, it's highly significant, so the chance that it's random is very low, but there's still a chance. So what you have to do again is to have some kind of solution where you control the force development at a certain velocity or something like this. A little bit more tricky, but again, very important, because I think now these air runners are used a lot, also more and more. And yeah, because you are usually long on one, yeah, on that machine, it can actually have a large effect as well on your overall rank. And this is also exactly what we see here.
Yeah.
Although I have to say the variance between the lanes is less than what we saw with the sledge in
Yeah.
this case, right? So it could be that it's less of an effect, likely, but it still is an effect. I mean, you see here the average rank, and these are a lot of people. You see, these are always one athlete, so it's like 12, 13 athletes. I mean, it's like 4 in lane 7, and yeah, 9 or 8 in lane 8. That's a on such a quite big amount of people. It's quite a
Yeah.
large difference,
Yeah. And I'm,
for sure.
quickly jumping back to the 2019 sled results. What's
Of course.
unfortunate is that the data we have, like the video footage, doesn't just show the whole field. And so all you can do is you have just the finish times. I mean, in a perfect world, you would have the time of like, when does the athlete start moving the sled until finish moving the sled? And then you take out well, how long did it take them to do the bar muscle ups or chalk their hands or spin the sled? And it's the same with this event. It's like, ideally you'd have like just the time from, running to finishing the run, as opposed to, how fast were their touch and go snatches, how fast was their transition. But it's just, we just don't have that, obviously, that data available.
Yeah, yeah,
But yeah, the thing with the runners,
yeah,
from my understanding, is that like
yeah.
they're not calibrated like at all. With a barbell, you weigh it. With a concept two, there's I'm gonna get the words
It's
wrong, but it has an internal mechanism that determines the amount of force, right?
yes,
Do you understand that better than me?
yes, that's correct. Slightly, I know it's auto calibrated. I know this. I've also read on some fora that they auto calibrate, and this should be indeed,
Yeah,
yeah, the case. I mean, again, I haven't seen studies on it where they actually measure, for example, what you could do on such a concept 2 bike. I don't know if this is done. Again, if people know that this has been done, please let me know, because that's very interesting. What you could do is change the pedals of a concept 2 bike, right? And you just put force measurement pedals, or watt measurements pedals in, yeah,
uh, yeah,
in the cranks, and then you assess the watts that it's provided on the machine, and you test this with a device where you actually measure the force on the pedals times the frequency of the rotations, and then you can very accurately assess the wattage, and also see if this actually is different between machines. So on a bike, it's doable, and it's actually not that, I mean, it's not that certain that they're all calibrated the same. I mean, the manufacturers say they are, but I'm not so sure about that, because I did myself these tests during my PhD, and even on very high profile, high level watt bikes, there were differences between bikes. All right, so yeah, that's one thing. But on a runner, I don't have the engineering knowledge to know if you can automatically calibrate them. There must be some way, because again, it's very
yeah.
important. I mean, as a organizing committee, and you need to know this, and maybe other people can jump in here, and I'm sure there's some knowledge
Yeah, I
about
mean,
this.
I think there was I always just kind of assumed that those machines were consistent between lanes. In the same way, you go to a competition,
Yeah.
you're not weighing the sandbags. You just assume like, oh, they poured the sand
No.
in and they made sure they're all exactly 200 pounds, maybe within a half a pound. They didn't just go like, yeah, they look the same. The sandbags look the same. They might be 10 pounds different, but they look the same. And so with the runners, and it's the same with the assault bike, it's the same with the echo bike. There's just a ticker, right? So just every time the wheel
Yeah.
turns, they say one, and then it turns
Yeah.
again and they go two.
Yeah.
And in the case of the runner, they probably measure out the entire track and they go, okay, the track is 2.3
Yeah.
meters. So every time you
Yes.
do a lap, you get 2.3 meters. And then if you do, 10 of those a minute, then it's like, oh, that's, 23 meters a minute. And then that's times six. That's how, 120 meters per hour, or whatever. Like that's how that's what the screen is saying. And so if you have one machine that's got a bunch of lubricant and oil, then it's going
Of
to be
course,
easier. And if
that's the
another
point.
one is covered in dust, then it's going to be
Yes.
harder. And so it's like, you know, can we determine what the difference is between those? Someone was saying to me something like, oh, you have a again, I haven't really thought of something that makes sense to me on how to test between runners if they're the same. Do you have any ideas on that?
Yeah, I had an idea. So again, it cannot be a
Mm-hmm.
human, but let's think about that it's a human. All right, you run, or it actually potentially even can be a human, at least in the first stage, where you run up until 15 kilometers an hour, then you jump off and wait how long it takes before the whole thing is a standstill. So
Yeah,
obviously, if there's less friction, it will take longer. If there's more friction, it will take shorter. And if you have then at least percentages, then at least you can know that there's a percentage difference between lane eight and seven, for example.
yeah,
That is actually a way that you could potentially do it. But the problem with that is, again, if it's a human, if with the last stride he pushes a
yeah.
bit more or less, this heavily affects. So, but I mean, again, mechanically, this must be possible to do this. I think just yeah, to let the band roll.
Yeah, that's a good.
I don't see too much problems
Yeah, and
with
I
that as
suppose what
well.
you'd want to do is you'd probably want to have you'd want to be filming it, and then what you would do is you would film that last few steps and then hopping off, and then you could go back to the film and really look at like,
Yeah,
okay, what's you could see the revolutions per minute, and then you could see that you instead of just doing like a hand timer on a little stopwatch, you could go to the footage and cut it and say, okay, this is exactly 4.83 seconds
yeah,
from the
yeah,
point of
yeah, yeah,
contact
yeah.
until letting
And
go. Yeah. That could work. I mean, it's a good starting point.
I mean, it's not perfect. It's not perfect, but it's a starting point to do in live competition, because I'm always thinking, how do you do this in competition? Because it's very important, because you can do a study and see that there's differences between surfaces. But yeah, I mean, if the lanes are different within that competition, you're nothing with your study. It still will have a
Well,
large effect, you
yeah,
know.
yeah,
So I mean, not nothing, but you know what I mean. It's still uh, the best way would be to have a relatively straightforward calibration method for each machine before each event, even not even competition
yeah,
event, because it could change. And it just I think it's yeah it's just very
yeah. Oh,
important.
yeah. I mean, people making or not making the CrossFit Games is can be pretty life changing, right? And so and you want the right people making it. Nobody wants to make it there unfairly either.
Yeah,
I think with talking about the sleds, talking about the runners, I think the first thing is just doing the testing for the sake of the testing and figuring out, like, are they
yeah,
consistent? How consistent are they, or
yes,
inconsistent? And then from there, you might have to do a secondary test and go, okay, well, now that we know how close they are, how far apart they are, what are some methods to
yeah.
to make them
This is the point.
consistent, or to at a competition with limited resources, not everyone's going to have like a laboratory with whatever. Like, what are some ways you can
No,
ensure and
no,
like control the variables? And so with the runners, for example,
yeah,
the obvious option is just get people to run on the road. um, but maybe it's like, okay, if we have the runners, what's the testing we can do? And then is there some area where we can, tighten something up or loosen something or lubricate to improve the consistency between lanes? It might be as
yeah,
simple as like, oh,
yeah,
you got a towel and you've got lubricant, and it's just like you open up this one spot and you do this testing and dot dot dot, you do the testing, okay, we're good. And that might bring it close enough
yeah.
where it's better than just not testing at all. Or if they're
Yes,
if they're
agree.
too far apart, do you have a backup? Do you have some stationary bikes? Do you have a running course athletes can take? um
Yeah,
I think that's like the secondary thing. But the first thing, and the same with the sleds, is to determine, like, are the athletes just complaining? And we could be, right? It's possible that you do a bunch of
yeah,
testing and you pour water and you have these runners, all these different runners at different ages. You go, damn, like they are all the same. Like, would you look at that? And then we're good. And I would love
yeah,
those results, right? But I mean, I think probably not the case. And then if so, it's like, okay, what's the actionable course? What's the course of action you can take in a competition setting as an event organizer, as
yeah,
an athlete,
yeah.
to, like, okay, how can we make these as consistent as possible, as consistently as possible? As many opportunities. And, like we were talking before the call started, the sleds are like last year at semis, we used the runners in 3 out of the 7 events, which was a lot. And then at the CrossFit Games from 2007 to 2023, we've had 17 CrossFit Games for individuals, and 5 years there were no sleds. 6 years had a sled, and then another 6 years had two sleds, or like two sled type. Whether that was hammering or pulling a dummy, and then some years legitimately just had you had two different sleds. So that's 12 out of 17 years had at least one sled in it. So it's as common as handstand walking, is what I was saying. Like I think we've handstand walked
Yeah,
at
yeah.
probably about 13 out of 17. So it's just as important. Yeah.
Yeah, it's
And it's
not
not
trivial.
trivial.
It's
Not at all.
absolutely not trivial, and should be should you? I mean, you and all the elite athletes are tested for doping
Hmm.
every whatever couple of weeks, a couple of months. This is as important. To be honest, technical doping. It's something that also happens in cycling. So at least there's some conspiracies there. So that's why I think as an organizer you have that. Duty to make it correct. And I'm happy to, I mean, and also your to use our platform to maybe gather some people, some scientists, to do these testings. Maybe even publish a study, like publish a manuscript about this. I think it's a very nice applied sciences. Happy to collaborate on that one. I just can't do it alone. I don't think I have enough engineering background, but I can definitely coordinate these kind of
Yeah,
studies.
same. I would, I'd love to. I definitely don't have the engineering background or the free time, but I'd be happy to jump on some calls and, make sure that the test is set up in a way that mimics what we're doing with it. I think is important as well.
Yeah,
Like
yeah,
where you sort of
it's
push,
important.
where you sort of pull, the types of weights we use, even things such as like, well, what's the average speed? So we can get it as close to possible. Like, all right, on average, this is where it's being pulled from. This is
I
where it's being
agree.
pushed from. This is about the weight that's being used. Halfway between the male and the female weight, and then even just thinking of it from in a competition setting, you usually have 10 lanes, 10 sleds. The assumption is all the sleds are brand new.
Yeah,
They might not be the exact same, but they're almost as identical as possible from a factory setting. And they're very similar if they're brand new.
yeah,
And it's like, okay, so how can we sort of mimic that in the lab? And then it's like, let's do, 20 laps on the same surface back and back and forth, because usually that's how it's done. And by that 20th lap, I think that
yeah.
even just that is interesting. Like, how much does the force change by the 20th lap in 2 hours? Like, is that heat making a difference from that, repetitive, the friction going back and forth? I think it'd be good information.
Crucially, I wanted to ask you this actually. So, if you would go onto this astroturf, right? You would go once back and forward. Are there actually kind of like lanes formed inside the turf? I guess so, depending on the
Well, and
sled.
also depending on the turf, like
So
there's
would
different types of
yeah,
turf. Some turf has the little
yeah,
rubber pellets, the little black rubber pellets. Most of the CrossFit events you go to do not have that. I mean, some do. We had that at Granite Games. We pushed a sled at Granite Games. It does create like some, you'll see the lines from above. You'll sort of, you'll see these lines being made, but it's more like when it's more like velvet or, suede or whatever when you push it back and forth, which like maybe matters a little bit. I would guess not so much. I think by the time you go over it again, it just sort of leans it over. Whereas obviously
it
with
goes
real
back. Yeah,
grass, it's like you're chewing it up, right? The cattail weirded me out there.
yeah.
But yeah, that's
Sorry.
another consideration, and yeah, and usually the lanes are kind of wide enough that you're probably not covering
You
that, like the
anyway.
even if intentionally or not,
Yeah,
you're probably not covering like the exact same track you did on the way out or the way in. Um, but yeah,
yeah.
yeah,
Yeah, so less of a factor, but
still
that's
something.
that's very good information, obviously, and that yeah, that's yeah. So I think, I mean, for me this is
Yeah,
quite clear what the study setup should be, how we gonna attack it, who we need an engineer, we need engineers who can manufacture or know of a machine that can pull at a certain velocity with a certain force. We need some sledges. We need a force measurement device, which is cheap. We need a field, and then we can do some field studies already, quite straightforward. And if any people want to help us out here, this would be very useful. Also for everyone in the CrossFit community going
Yeah,
forward, I
yeah.
would
No,
say.
I'll be sharing this on my channel and on my social channels. Make
Okay.
sure to get the word out, and hopefully we can find
Okay.
some people that are eager to help. And yeah, definitely do it on turf. And I know the type of turf that they used at the games in last few years in Madison. Not that but there's obviously different types of turf, and so if we can find one that's as similar to that as possible, would be
Yeah.
great. And then, yeah,
Yeah.
even
Yeah.
finding
Of course.
some rubber, sorry, that's similar to what they see that we see at competitions would also be great. So, but no
Yeah.
shortage of things to test. It'd be fun.
Okay, yeah, that's for sure. Great master thesis or bachelor thesis
Yeah,
project, I think. No, okay, Brent. Then I'm gonna
yep,
stop it here. I think the information is clear and super nice chatting with you. I think you're onto something, and I think it's very important as well. That's why I like
yeah,
it
sounds
for
good.
sure.
Thanks for the time.
Okay, good. Thank you. Bye.